Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form the partial differential equation by eliminating the arbitrary constants from x minus a whole square plus y minus b whole square plus z square equal to a square plus b square. Right, now we are asked to find or form a partial differential equation by eliminating the arbitrary constants a and b from the given equation. Okay. Here x and y are independent variables and z is a dependent variable. Okay, or z is a function of x and y, where x and y are independent variable, we can say, and a, b are constants, arbitrary constants. Fine. Now we are asked to find partial differential equation. We are asked to form partial differential equation from the equation x minus a whole square plus y minus b whole square plus z square equal to a square plus b square, right? Consider it as equation 1. Now let's see the detailed process of finding PDE, and later we'll see the same problem by decreasing the number of steps. Partially differentiating 1. With respect to x. So here we are partially differentiating the given equation with respect to x. We'll treat y as constant. Okay, just apply dou by dou x on both sides of the equation, that is equation 1. Which gives us dou by dou x of first term plus dou by dou x of second term plus dou by dou x of third term equal to dou by dou x of, here a square and b square are constant. You can just simply put 0 here, otherwise we can write one more step. Right? So partial derivative of x minus a whole square with respect to x is 2 times x minus a into inner derivative, that is partial derivative of x minus a, plus, since we are partially differentiating the terms with respect to x, so we'll treat y as constant. Here y minus b is treated as constant, and here partial derivative of a constant with respect to x will be 0, plus partial derivative of z square with respect to x is 2z into dou z by dou x equal to partial derivative of a constant with respect to x is 0 plus partial derivative of a constant with respect to x is 0, right? This gives us 2 times x minus a into partial derivative of x with respect to x minus partial derivative of constant a with respect to x plus 2z into, here we have a notation dou z by dou x equal to p. So let's replace it by p. You'll get 2zp equal to 0, right? This gives us 2 times x minus a into partial derivative of x with respect to x is 1 minus partial derivative of a constant with respect to x is 0 plus 2zp equal to 0, which gives us 2 times x minus a into 1 plus 2zp equal to 0. So you can skip the steps which are avoidable. Now I'll take this term to RHS. You'll get 2 times x minus a equal to minus 2zp. Just cancel 2, then you'll get x minus a equal to minus zp. Consider it as equation number 2. Now partially differentiate 1 with respect to y. Since we are partially differentiating 1 with respect to y, so we'll treat x as constant, right? Just apply dou by dou y on both sides of 1. dou by dou y of x minus a, that is the first term, plus dou by dou y of second term plus dou by dou y of third term equal to dou by dou y of first term of RHS. You can directly write 0 because a square and b square are constant, so partial derivative of constant is 0, right? You can just directly write 0. Here we are partially differentiating with respect to y, so x is treated as constant. We'll treat x minus a whole square also as constant. So partial derivative of a constant with respect to y is 0 plus partial derivative of y minus b whole square with respect to y is 2 times y minus b into dou by dou y of, inner derivative, dou by dou y of y minus b plus partial derivative of z square with respect to y is 2z into dou z by dou y plus equal to partial derivative of a constant with respect to y is 0 plus partial derivative of a constant with respect to y is 0, right? Which gives us 2 times y minus b into partial derivative of y with respect to y minus partial derivative of b constant with respect to y plus 2z into, since we have a notation dou z by dou y equal to q, so let's replace dou z by dou y with q. You'll get, okay, equal to 2 times y minus b into partial derivative of y with respect to y is 1 minus partial derivative of a constant with respect to y is 0 plus 2zq equal to 0, right? Which gives us 2 times y minus b into 1 plus 2zq equal to 0. This gives us 2 times y minus b plus 2zq equal to 0. Now take this second term to RHS. We'll get 2 times y minus b equal to minus 2zq. Cancel 2. Then we'll get y minus b equal to minus zq. Consider it as equation 3. Now observe 1, 2 and 3. See, x minus a can be replaced by minus zb where this a gets eliminated. Likewise, y minus b can be eliminated using 3 by replacing it by minus zq where this b gets eliminated, and likewise you can just get a using 2 and b using 3, so that all the constants, arbitrary constants of 1 gets eliminated, and finally you'll get the partial differential equation from this. Simply substitute 2, 3 in 1. We have 1 x minus a whole square plus y minus b whole square plus z square equal to a square plus b square. Now substitute 2 and 3 in 1. By 2, you can just replace x minus a by minus zp whole square, since x minus a equal to minus zp, y minus b equal to minus zq. Replace y minus b using 3, okay, plus z square equal to, you have a, right? Since we have x minus a equal to minus zp, now take this a to RHS and bring this zp to LHS. You'll get x plus zp equal to a. Just replace this a by x plus zp whole square. Likewise, using 3, y minus b equal to minus zq. Okay, take this b to RHS and bring this zq to LHS. You'll get y plus zq equal to b. Just replace this by b by y plus zq whole square, right? Fine. This gives us minus zp whole square is z square p square, minus zq whole square gives z square q square plus z square plus expand equal to expand x plus zp whole square, will get x square plus z square p square plus 2xzp plus expand y plus zq whole square, will get y square plus z square q square plus QYZQ, right? So you can cancel Z square, P square and Z square, Q square from both the terms, or just take all the terms to LHS. Okay. See, well, instead of taking all the terms, I'll just take Z square, P square and Z square, Q square to LHS, so that I'll get Z square, P square plus Z square, Q square minus Z square, P square minus Z square, Q square equal to X square plus Y square plus 2x ZP plus 2y ZQ. Z square P square minus Z square P square, Z square Q square minus Z square Q square. Here you have one more Z square, right, plus Z square equal to X square plus Y square. Okay, this gives us Z square equal to X square plus Y square plus, you can just take 2Z common from these two terms, so I'll get 2Z times XP plus YQ. Which is the required partial differential equation. See, it does not involve any arbitrary constants, and also this equation is of the form f of x, y, z, p, q equal to 0, right? Therefore, z square equal to x square plus y square plus 2z into xp plus yq is the required partial differential equation. Now let's see the shortcut. So we are given an equation. Now we need to find partial differential equation from this. We need to form partial differential equation from 1. Now we'll partially differentiate 1 with respect to x. Partial derivative of x minus a whole square is 2 times x minus a whole square into inner derivative. Partial derivative of x with respect to x is 1 minus partial derivative of a constant with respect to x is 0 plus partial derivative of a constant with respect to x is 0 plus partial derivative of z square with respect to x is 2z into dou z by dou x equal to partial derivative of constants with respect to x is 0. And this gives us 2 times x minus a whole square into 1 is 2 times x minus a whole square plus 2z into, since we have dou z by dou x equal to p, so let's replace it by p. You'll get 2zp equal to 0, right? So you'll have 2 times x minus a. Derivative of partial derivative of x minus a whole square is 2 times x minus a into inner derivative, that is partial derivative of x with respect to 1 minus partial derivative of a constant with respect to x 0. Okay, which gives us x minus a equal to minus zp by cancelling this 2. Now partially differentiate 1 with respect to y. Partial derivative for constant with respect to y is 0 plus partial derivative of y minus b whole square is 2 times y minus b into inner derivative. Partial derivative of y with respect to y is 1 minus partial derivative of a constant with respect to y is 0 plus partial derivative of z square is 2z into dou z by dou y equal to partial derivative of a constant with respect to x is 0. Sorry, with respect to y is 0. You'll get 2 times y minus b into 1 is y minus b plus 2z into, since we have a notation dou z by dou y equal to q, let's replace dou z by dou y by q. You'll get 2zq equal to 0. Now this gives us y minus b equal to minus zq. Okay, or you can just include one more step for your convenience. Cancel this 2, then you'll get y minus b equal to minus zq. We have considered this equation as 2 and this one as 3, right? Now observe 1, 2 and 3. Just substitute 2 and 3 in 1. We have 1 x minus a whole square plus y minus b whole square plus z square equal to a square plus b square. Now substitute 2 and 3 in 1. Substitute 2 and 3 in 1. We get, replace x minus a by minus zp, you will get minus zp whole square plus replace y minus b by minus zq using 3, using this 3, okay, plus z square equal to, using 2 you will get x plus zp equal to a, right? Just replace this a by x plus zp, you will get x plus zp whole square, and replace this b by y plus zq equal to b. Using 3 we will get y plus zq equal to b, right? We will replace b by y plus zq, we will get y plus zq whole square. This gives us z square p square plus z square q square plus z square equal to x square plus z square p square plus 2x zp plus y square z square q square plus 2y zq. Now bring this z square p square z square q square to LHS. You'll get z square p square plus z square q square minus z square p square minus z square q square plus z square. See, in the first procedure I just missed this as z square. I wrote it again, but while going the flow I just forgot to write just x square there, equal to x square plus y square plus take 2z common from these two terms. You'll get 2z times xp plus yq, where z square p square minus z square p square gets cancelled, z square q square minus z square q square gets cancelled, which gives us z square equal to x square plus y square plus 2z into xp plus yq, which is the required partial differential equation, since which is of the form, this is of the form f of x y z p q equal to 0, right? It does not involve any arbitrary constants. This completes the problem. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next day. Until then, bye bye.